So, to finish up our ocean unit, we're going to talk about oceanic trench zone. Here's a simple infographic just to show you what the trench is, okay? So up here is the twilight or the sunlight zone with the continental shelf. And then you get a little further down and it's the twilight zone. Then you have the midnight zone. And then you have the trench zone, okay? And so that's really, really deep. It goes down 10,000 meters. Ocean trenches are long, narrow depressions on the seafloor. These chasms are the deepest part of the ocean and some of the deepest natural spots on Earth. This one's a little not as user friendly, but the Mariana Trench, they're showing right here what it looks like. It's the deepest trench in the world. Ocean trenches are the result of a process called subjudication, where dense oceanic crust slides beneath less dense crust. The red arrow indicates subduction zone forming the massive Mariana Trench. Okay, so it slides down underneath. Okay, so here's just a quick video. So sonar is when they send sound down through the water and it bounces back. And the way it bounces back shows what the ocean floor looks like. It's not a perfect science, but it's all really we have at the moment. So most of the trenches are along the Ring of Fire, which the Ring of Fire, as you can see here, goes from around Australia, up through New Zealand, through Japan, uh, off the coast of Alaska, off the coast of Russia, down through California, down through Mexico and Chile. Okay. So this is where a lot of the earthquakes happen. This is also where there's a lot of active volcanoes, because since the ocean floor and the Earth's crust is always moving, this is where it moves the most. Okay, so the Mariana Trench, including the Challenger Deep, the deepest spot on Earth, is formed where the mighty Pacific Plate is subducting beneath the less dense oceanic crust of the Philippine Plate. So here's the Mariana Trench, and here's the deepest part. So we don't have as much technology to be able to go down there and see everything that's down there because it's so much pressure and it's so dark. Ocean trenches can contribute to the formation of volcanic arcs, island mountain chains that run parallel to the trench. This island chain, swinging out from the Alaska Peninsula, run parallel to the trench, where the Pacific Plate is subducting beneath the North American Plate. Not all ocean trenches ring the Pacific, of course. There's a Puerto Rican trench, the deepest spot in the Atlantic Ocean, and it's created where the oceanic crust of the North American Plate, carrying the western Atlantic Ocean, is being subducted beneath the oceanic crust of the smaller Caribbean Plate. There's a trench near us, too, so it's near Puerto Rico. So, the deep sea ecosystem, the deep sea has crazy things like we've talked about before. Some of these we see in the twilight zone and the midnight zone. Some of them also come up to feed in the sunlight zone at night. So many of these organisms are well adapted to survive in the deep ocean trenches, but in order to see in the dark and find food and mates, they use their bioluminescence. Um, In order to survive the intense pressure, many organisms have soft, gelatinous bodies. So here's your Dumbo octopus, which I think is seriously the cutest octopus ever. Your firefly squid, your viperfish, which we talked about, jellyfish, this crazy eel-like thing that is completely see-through, but it's got like links, and it's so cool. I saw a video of one of these when they were looking for a giant squid. Here's a giant squid. Look at this pelican eel. It's got a mouth like a pelican, but it's an eel. Wow. Anglerfish, vampire squid. Cool. Um, there are few food sources in the cold, isolated, and high pressure habitats of deep ocean trenches. Marine snow, which is the steady fall of organic matter from higher in the water column, is a vital source of nutrients. Marine snow may include decaying parts of dead organisms or fecal matter, and also krill. Lacking sunlight, photosynthesis is impossible in the deep ocean trenches. Instead, producers in this unusual food web convert chemical compounds such as methane into nutrients, a process called chemosynthesis. The orange bacteria mat above is part of a chemosynthetic community, though not an ocean trench. So these things live near hydrothermal vents, and they convert the gases that are coming out of the vents in the bottom of the ocean and um, basically eat the gas. So, and then bigger fish eat that, and so on and so forth. So, ocean trenches are among the most remote places on the planet. Only 3 people have ever descended into the Challenger Deep. 2 of them, Jacques Piccard and Don Walsh, did so in this vessel, the Bathyscaphe Trussee, in 1960. Wow. So let's see here. Ocean trenches are long, narrow depressions on the seafloor. These chasms are the deepest part of the ocean and some of the deepest natural spots on Earth. Ocean trenches are found in every ocean basin on the planet, although the deepest ocean trenches ring the Pacific as part of the so-called Ring of Fire that includes active volcanoes and earthquake zones. Ocean trenches are the result of tectonic activity, which describes the movement of the Earth's lithosphere. So basically, it means earthquakes moving the crust. In particular, ocean trenches are a feature of the convergent plate boundaries, where 2 or more tectonic plates meet. At many convergent plate boundaries, dense lithosphere melts or slides beneath less dense. So basically, when the crust is moving, it's because the Earth's crust is separated. There's always some movement. So the plates are separated. So there's movement. So when a trench forms, what happens is it goes underneath the other plate and forms a trench. Okay. So that's how we get earthquakes, is when the plates rub up against each other and it creates the earthquakes, and then it creates waves and tsunamis and stuff. So the trenches form that way too. Ocean trenches occupy the deepest layer of the ocean. The intense pressure, lack of sunlight, and frigid temperatures make ocean trenches some of the most unique habitats on Earth. We learned about how they form. So, life in the trenches. Ocean trenches are some of the most hostile habitats on Earth. Pressure is more than 1,000 times that on the surface, and the water temperature is just above freezing. Perhaps most importantly, no sunlight penetrates the deepest ocean trenches, making photosynthesis impossible. Organisms that live in the ocean trenches have evolved with unusual adaptations to thrive in these cold, dark canyons. Their behavior is a test of the so-called visual interaction hypothesis, which states that the greater an organism's visibility, the more energy it must expend to catch prey or repel predators. In general, life in dark ocean trenches is isolated and slow-moving, because you don't want to expend too much energy if you don't have food to eat. The pressure at the bottom of the Challenger Deep, the deepest spot on Earth, is about 12,400 tons per square meter. That means 8 tons per square inch. Let's do some simple, quick math. So, a ton is 2,000 pounds, okay? So, 8 tons per square inch. So, 8 times 2 is 16. So 16,000 pounds for an inch of water in the trench. You would be squished flatter than a pancake. There would be nothing left of you. That's insane. So large ocean animals such as sharks and whales cannot live at this crushing depth, which, yeah. Many organisms that thrive in these high pressure environments lack gas filled organs such as lungs. These organisms, many related to sea stars or jellies, are made mostly of water and gelatinous material that cannot be crushed as easily as lung or bones. Many of these creatures navigate the depths well enough to even make vertical migration of more than 1,000 meters from the bottom of the trench every day. And remember, we talked about how a lot of the critters in the midnight and twilight zone migrate to the sunlight zone to hunt. Same thing happens with the trenches. Even the fish in the deep trenches are gelatinous. Several species of bulb-headed snailfish, for example, dwell at the bottom of the Mariana Trench. The bodies of these fishes have been compared to tissue paper. Think of tissue paper and how it just like rips. When it gets wet, it just kind of disintegrates. It's pretty amazing. Shallower ocean trenches have less pressure but may still fall outside the sunlight zone, where light penetrates the water. Many fish species have adapted to life in these dark ocean trenches. Some use bioluminescence, meaning they produce their own light, in order to attract prey, find a mate, or repel a predator. Anglerfish, for instance, use bioluminescent growth on top of their heads called to lure prey. The anglerfish then snaps up the little fish with its huge toothy jaws. Without photosynthesis, marine communities rely primarily on two unusual sources for nutrients. The first is marine snow, which we talked about, which is the stuff that's falling down and floating down into the trenches. So organic waste, poop, things like that. This nutrient-rich marine snow feeds such animals such as sea cucumbers and vampire squids. Another source of nutrients for the ocean trench food webs comes not from photosynthesis but from chemosynthesis. Chemosynthesis is the process which produces in the ocean trench, such as bacteria, convert chemical compounds into organic nutrients. The chemical compounds used in chemosynthesis are methane or carbon dioxide ejected from hydrothermal vents and cold seeps, which spew these toxic hot gases and fluids into the frigid ocean water. One common animal that relies on chemosynthetic bacteria for food is the giant tube worm. So they take gases that would normally kill most things on Earth, and they eat it. It's pretty awesome. So ocean trenches remain one of the most elusive and little-known marine habitats. Until the 1950s, many oceanographers thought that these trenches were unchanging environments nearly devoid of life. Even today, most researchers on the ocean trenches has relied on seafloor samples and photographic expeditions. That's slowly changing as explorers delve into the deep. Literally. The Challenger Deep at the bottom of the Mariana Trench lies deep in the Pacific Ocean near the island of Guam. Only 3 people have visited the Challenger Deep, the deepest ocean in the world: a joint French-American crew, Jacques Piccard and Don Walsh in the 60s, and National Geographic explorer-in-residence James Cameron in 2012. 2 other unmanned expeditions have also explored the Challenger Deep. Engineering submersibles to explore ocean trenches presents a huge set of unique challenges. Submersibles must be incredibly strong and resilient to contend with strong ocean currents, no visibility, and intense pressure of the Mariana Trench. Engineering a submersible to safely transport people, as well as delicate equipment, is even more challenging. The sub that took Piccard and Walsh to the Challenger Deep, the remarkable it's French, I can't pronounce it, was an unusual vessel called a Bathyscaphe. The Deep Sea Challenger Cameron submersible successfully addressed engineering challenges in innovative ways. To combat deep sea currents, the sub was designed to spin slowly as it descended. Lights on the sub were not incandescent or fluorescent, but tiny arrays of LEDs that illuminated an area about 30 meters. To adapt the pressure of the deep, the sub was shaped like a sphere. The walls of a square or cylinder-shaped vessel would need to be at least 3 times thicker to avoid being crushed. The sub's fuel was augmented by seawater to prevent the oil from compressing. Perhaps most startlingly, the Deep Sea Challenger itself was designed to compress. Cameron and his team created a glass-based synthetic foam that allowed the vehicle to compress under the ocean's pressure. The Deep Sea Challenger came back to the surface 7.6 centimeters smaller than when it descended. Wow, it's pretty awesome. So here are some animals that we would find in the trenches. Giant tube worms, fish, cusk eels. Now let's see here. So these are what the tube worms look like. It's kind of cool. Giant tube worms, starfish, worms. They're single cell organisms. Cusk eels. So giant tube worms, the scientific name for the giant tube worm is that. Tube worms were discovered living in the deep sea waters under what's called hydrothermic vents, also called black smokers. These vents are filled with chemicals and minerals to produce what scientists refer to as toxic soup. The soup is deadly to most animals, but whole ecosystems of animals survive close to these black smoke vents. In this environment that the giant tube worm exists. Giant tube worms can grow 8 feet or more and do not have mouths or digestive tracts. They survive on the symbiotic relationship they have with bacteria living inside them. Although starfish are most commonly seen on beaches and in shallow ocean water, as a species they're quite adaptable and are also found in the deep waters of the trenches. The name fish is a misnomer. A starfish is not a fish, but rather an ectoderm. An echinoderm is in the same family of sea urchins and sand dollars, which use seawater to pump food through their bodies. Some scientists have begun to call starfish sea stars as a way to distinguish them from fish. Foraminifera, or forearms. Forearms are protists that are free-living single-cell organisms. Given that forearms live in the deepest waters of the sea, they have very unusual processes for acquiring nutrition and reproducing. They have shells covering their bodies. These shells are generally separated into chambers. Shells are made of either organic mixtures, grains of sand combined with other particles, or crystalline calcite. The exact composition of the shells is related to the specific species. These organisms are so small they cannot be seen with the naked eye. Let's see if we can pull up a picture. Oh, look at that. So they look like they're just cells, but they're covered in a shell. That's pretty cool. Cusk eels. Cusk eels live in the deepest water on the planet and is a species of fish. These fish have been seen all really, really. I'm trying to. Sorry about that. Oh my god. All right. So that's basically the oceanic trench zone. So we learned about the sunlight zone, we learned about the twilight zone, the midnight zone, and now we just learned about the ocean trench zone. Um, so it's pretty awesome. The ocean is amazing. I'll be try to post some videos more about the Mariana Trench. Have a fun day.